Welcome to FMA 0146 Basic Mathematics. In, in this video, we are going to discuss equations which are involving surds, indices, and logarithms. Let us look at the first one, surd. They are not say types, but there are few of the possibility. The first one is only have one surd in the equation. The second one is we have two or more surds in the equations. The way to solve this equation involving the surd is we squaring both sides. Why we need to squaring the both sides? Actually, this is the intention to get rid of the surd. Okay, so our strategy is first thing is keep our surd on one side of the equation. After that, we keep on squaring so to get rid of the surd. After that, there is one important task to do is we need to substituting back the value that we found into the original equations to verify our answer. Okay, so let us look at the first one. We need to solve square root of 2x plus 1 equals to 5. So, first thing, we only have one surd. After that, what we need to do is, we check is it our surd is on one side of the equation or not. Okay, square root of 2x plus 1 is on my left hand side and my 5 is on my right hand side. It's fine enough. So, our strategy is squaring both sides. So remember, square root we also can written as 2x plus 1 power of half, and the whole thing when we are squaring, so means we can simplify, and what we will get is 2x plus 1. So whenever you see in square root, when you are squaring it, and then you will get it of the surd. So on the left hand side, I have 2x plus 1, and on my right hand side, pi power of 2 is 25, and we simplify this simple linear equation, and then we have 2x equals to 24, and then x equals to 12. As I said, we need to do some checking, so we substituting x equals to 12 into our original equation. Then when we substitute 12 into here, then we have the square root of 25 is 5. So then means that x equals to 12 is our answer. Then after that, the second example is surd. So for this second example, we also having our surd on our left hand side. So, but the thing is on our right hand side have more than one terms. It doesn't matter as long as our strategy is isolating one surd on one side. The rest of it we move it to the other side. Okay, so when we square in both sides, the left hand side is become 2x plus 5. What happened to our right hand side? Still remember we have the a plus b square. Actually by formula is a square plus 2ab plus b square. So over here my a is an x and then my b is an 1. So a square so is an x square plus 2ab, so 2x and 1 is 2x, and then 1 square. After that, this one simplified this equation, so I have an x squared minus 4 equals to 0. You can substitute in, you can calculate this, you can solve these quadratic equations by using the calculator, and then calculator provide us two answer. One is x equals to minus 2, another one is x equals to 2. At the same time, we need to check regardless how many answers we obtain. So the first thing I check by substituting x equals to 2 into our original equations, and then the left hand side I obtain 3 and my right hand side also 3, so I have the true statement. What happens if I substituting x equals to negative 2 into my original questions? So on the left hand side, I have a square root 2 negative 2 plus 5 equals to negative 2 plus 1. On my right hand side is negative 1. On my left hand side is 1. So this thing is a false statement. So I only have one answer, that is x equals to 2. Then how about the number 3? Example number 3. Okay. Although it is only have one set, but this one set come with one friend, that is minus x. So this one is against our strategy, which is we need to isolate our set on the left hand side or one side. So I shifted my minus x into the right hand side. So my right hand side is x plus 3. Now my left hand side have an standalone set. So now what we do is we square it both sides. And then the right hand side is x squared plus 2ab plus b squared. Simplify, and then by using calculator, the answer for the x is negative 2 and 8. So substituting 8 and negative 2 into the original equation, and then both are giving us the true statement. So my final answer is minus 2 and 8. Let us look at example 4. Okay, now this example 4 are different from example 1 to 3, which is I have more than one set, that is 2. Okay, the strategy is still the same. That is, keep one set on one side. So only one set at one time. So then what we do is we shifted our second set into the right hand side. Maybe you will ask, so what happened here? On my right hand side, I have a set and a bodyguard. Okay, doesn't matter. We do it slowly. That is, we kill one set first. Okay, so how we going to kill this one set? Set. So what we do is we squaring both sides. Okay, so after we squaring both sides, we already killed our first set. Yes, we do still have our second set. Doesn't matter. We redo or we repeat our strategy. Keep our set on one side. That is this is on the right hand side. 4 plus 4 set 2x. 2x plus 4 we shifted to the other side. We have 4 set x equals to 3x plus 2. Now we do the strategy again, squaring both sides. And then remember this squaring, set is disappeared, is become 2x. And 4 square is 16. And then this is a square plus 2ab plus b square. And simplify. Okay, and this one key in into calculator, and the calculator give you 2 and 2 over 9. And we substituting back into the original equations, and both are true. So our answer is 2 over 9. The next one over here, this is I took from your module. Okay, now this module, these questions. Okay, let's say we have a general equation which is not insert first. So when you have 1 over p plus 1 over q, when you want to solve this type of question, what we do is we equate our denominator by cross multiplying q plus p equals to 0. Okay, and the first condition is our p cannot be 0 and our q cannot be 0. Why? Because 1 over 0 is undefined. Okay, so that's why p and the q cannot be 0. And since our pq cannot be 0, this one cannot be 0, so means that my numerator must be equals to 0. If not, that this equation is impossible to become 0. Okay, so we change our p becomes set x, our q become set x plus 3. So we can solve this equation by cross multiplying, and then the denominator, which is set x and set x plus 3, cannot be 0. So now my numerator set x plus 3 plus 2 set x must equals to 0, and then our applied by our strategy. Keep one third on one side, so I shift my second third to the other side, become minus 2 third x, and squaring both sides. The left hand side is x plus 3, the right hand side is 4x. So, and then we solve for it, x equals to 1. Maybe at this moment you are quite happy that is you only have one answer, and most of the time you will think that is only one answer, so I no need to check my answer. No. If you look at it, when we substituting x equals to 1 into the equations, we found that the left hand side actually is equals to 2, which is not equals to 0 as our original equation. So it means that this statement is false. So our conclusion is 1 is not a solution, so there is no solution for the above equation. Okay, so let us have some practice. Okay, so this one, the first question 1, our strategy keep one third on one side, so the negative 3 shifted to the other side, so I have third p minus 2 equals to 3, and step 2, squaring both sides, so I have p minus 2 equals to 9, so p equals to 11. And remember, checking square root, 11 minus 2 minus 3 actually is 9, square root of 3 minus 3 actually is 3 minus 3, which is 0, so that means it's true, so this one is my answer. Okay, so how about the second one? Since my right hand side have one third only, so I only need to square in both sides. So left hand side, a square minus 2ab plus c square. Okay, and the right hand side is 7 minus t, and we collect everyone together, t square minus t plus minus 6 equals to 0. So you can actually you no need to do the factoring. You can by using the calculator. So t is going to give you 3 and t is giving you negative 2. As usual, you will need to do the checking. So when 3 minus 1 equals to square root 7 minus 3, so this is 2, 2, this one is true. And then when we have a minus 2, minus 1 equals to square root 7 minus 2, this one is 3. This is negative 3, this one is invalid, false. So my final answer, t equals to 3 only. Okay. Now we look at the question 2. Okay, solve this one for the real roots. Okay, so what it means by real roots? Means that your x must be a real number. They are the cases that when your x is a complex number. When your x is a complex number, you need to reject that particular answer. Okay, regardless you have one third or two third or more third, doesn't matter. Our strategy always is the first one. Isolate one third at one side. Okay, so then after that, squaring both sides. Okay, so now this one I just is my first third, this is my second third, so I send my second third to the right hand side. Okay, so 2x plus 1 equals to 2 minus square root 2x minus 1, and now applying the squaring, so the left hand side is 2x plus 1, the left hand side is a square minus 2ab, and then plus b square. Okay, so now simplified. Okay, this one and this one disappeared. Plus 1 and minus 1. Okay, 4 minus 1 actually is 3. 3 shifted here is negative 2 equals to negative 4 third 2x minus 1, and then we now, since this is only one square root, so then we just squaring both sides. 4 equals to 16, third, sorry, there's no more third, then 2x minus 1, and then 4, and this is 4, so I have 1 over 4, 2x minus 1, then my 2x actually is equals to, this one shifted here, is 5 over 4, and my x is 5 over 8. Okay, as I said, although it is only one answer, but we still need to do the checking. Substituting back into this original, 2, 5 over 8 plus 1 plus square 2, 5 over 8 minus 1. The answer should be equals to 2, which is our right hand side. Okay, then how about this question? There is no difference. Okay, so although this is the difference actually with the previous question, this is minus, this is plus. So this doesn't cause any problem. The strategy is still the same. Keep one third at one side. So x plus 1, 1 plus third 1 minus 2x. Squaring both sides. X plus 1, 1 plus 2, third 1 minus 2x, 2ab, plus 1 minus 2x. Okay, so now this is 1. Okay, this 1 and this 1 disappeared. So this is minus 2x. Shifted to the other side is 3x. Minus 1 equals to 2, third 1 minus 2x. Maybe you ask why I never simplified these two. Because when I bring these two to the other side, it's become dividing 2. When dividing 2 and then squaring it is going to cost me fraction. So I don't like to have a fraction. So that's why I keep these 2 over here. So what we do, this one is squaring. This is squaring. This is 4. 1 minus 2x. My left hand side is become 9x squared minus 6x plus 1, and this one actually is 4 minus 8x. Okay, so we simplify everything. 9x squared plus 2x, then minus this is 4, this is 1, so minus 3 equals to 0. If you see this thing is not the kind that quite easy for you to simplify, so you use you can key it into the calculator. Okay, now as I said before, in the market, generally we have 3 types of calculator. The first one is a black one, the second one is the silver, and the third one is the white one. Okay, and all what I mentioned is all are casual. I never encountered any Canon calculator before, so normally I only use casual. Okay, now the black color calculator will produce the decimal answer only. They will never produce a third answer for you. Okay, so if you have the silver or the white one, the calculator will provide you 2 third 7 minus 1 over 9 and 2 third 7 plus 1 over 9. Okay, so this is what the calculator provided to you, or your calculator maybe is going to give you 3 point something something and negative 6 point something something. Okay, at this if in the exam come out this type of questions, you can answer it with the decimal point. Okay, it doesn't matter, but for the practice purpose, you can always use x equals to negative b plus minus b squared minus 4ac square root over 2a. This one is going to give you the root of ax squared plus bx plus c equals to 0. Okay, so now since I have 2 different answers, as usual, I need to substituting back these 2 answers for the checking into the original. Okay, and if you see over here only have 1, so that means the other one it has been rejected. Okay, so that one I left it for you to do your own checking. Okay, so now we move into the second types involving indices. Okay, in indices also we will see two different type of questions. The first one is when you change the base is sufficient enough. So means that we only compare the base. Okay, so means that when my base are same, so means that our index or our exponent must be equal. Okay, remember that this one they're telling you ax equals to ay because both base are similar, so your x is equals to y. It's not that you cancelling these two, okay? Actually, is you are do the comparison. Okay, and then the second type is a little bit not say advanced. They need you have an extra creativity, that is you see certain shape. Okay, I call it as a shape. Okay, just like this one, I call it as a shape. That is, you need to manipulate this shape, or you recognize this one as an object. Okay, so then you can solve the quadratic equation. After that, you change back to solve for x. Okay, so let us look at what I meant by this one. Okay, so the first one is the first type. You only need to change the base. Because this is base 3, 81 is still able to change to base 3. So I change to base 3 is 3 power of 4. So when my base are similar, so means that our exponent must be same. So my x equals to 4. Okay, then the second one are the same. So either you want to change 32 equals to 2 power of 5 on the left hand side, or you can shift it to the other side and change it to base 2 also can, doesn't matter. Okay, so once my base are the same, then I will say that my exponent are the same. X plus 1 is equals to 5. My x equals to 4. Okay, this one, the third equation, the third question is seems like a little bit more complicated, but the way to do it are the same. That is, change to the similar base that you like. Okay, over here we have 16, we have 4, we have 64. Okay, one thing we can easily recognize, they all are base 2 and they are all base 4. If you say that you are good enough, you say they are base 8, 16 or 64, doesn't matter. So only over here we only is going to show two different base only. The first one is base 2, the second one is base 4. Okay, so if I change to base 2, everything I change it to base 2. 16 is 2 power 4. If I want to change 4x minus 1 into base 2, so what is 4? 4 is 2 power of 2, and don't forget the original power is x minus 1. So that's why I have a 2x minus 1. And then 64 actually is 2 power of 6. And then because for us to do the comparison, I make it to become a negative exponent. So I have 2 power of negative 6. And then still remember the properties of our index. We have a Pm multiplied Pn equals to Pm plus n. So I can sum my P plus 2x minus 2 equals to 2 power of negative 6. Since the base are the same, so we have 2x plus 2 equals to minus 6, and then my x equals to negative 4. And then, or the second way, that is we change it to base 4. Since we don't want to change the 4 to base 2, then 16 is 4 power of 2. Then this one copy back. And 64 actually is a 4 power of 3. And then the same thing, we make it to become a negative exponent. So, and then using the same thing, Pm multiplied Pn is Pm plus n. So, and then we do the exponent comparison. So my x equals to negative 4. Okay, for the indices, we no need to do the checking. Only the surds and logarithm, we need to do the checking. So this one, we know that our final answer is x equals to negative 4. Okay, so let us look at another one question. For x, 4x minus 1 minus 6. Okay, so now this is the time that is we need to recognize what is our object or what is our title. Okay, so what is our shape that we want? Okay, actually over here when we have a 4x and 4x minus 1, we know they are similar, but this one we have a minus 1. Okay, for 4x versus 4x minus 1, it is quite difficult for us to change 4x into the terms of 4x minus 1. You can actually is 4 multiplied 4x minus 1 is the 4x, but this one, it seems like actually this one is equals to 4x, but it seems that it's more difficult. Okay, it's or more, maybe it's more confusing, so that's why we always change our 4x minus 1 into the 4x. How? By 4x minus 1 actually is 4x divided by 4, so I have a 4x. Okay, so over here now we already have the same object. Okay, so now if why I keep on saying the object, okay, so now if we can recognize 4x as an object, straight away I change my 4 power of x equals to u. So the similar equations, I already changed it to become u minus u over 4 minus 6 equals to 0. Why I want to do so? Because if you look at this one, some people will be getting confused how to solve this thing, how to solve this particular thing. Actually, maybe some of you can say that it is quite easy. I have a 4 apple minus 1 apple. Okay, so that's why I have a 4x. But maybe some of you couldn't identify this one as an object, so that's why we come up another way for you to recognize. We change our 4x into u, so I have a u minus u over 4 minus 6, so I have a 4u minus u, so I have a 3u over 4. So, and then what is my u? U actually is 4x, so we replace back. Okay, why we need to replace back at the end? Because our objective is finding the value of the x. Okay, so now when I know that my 4x equals to 8, so I change both into base 2. Then when the base are the same, 2, so my exponent are the same, 2x equals to 3, my x equals to 3 over 2. So as I say this one, if you know, okay, if you can recognize, this is 4 apple minus 1 apple, you have 3 apple. So now when we want to solve for the apple, so that's why we revert 4 times 6 divided by 3 is 8. Okay, so then we solve the same way. Okay, and now when we go to the second type of questions, okay, this one, when you look, is quite similar to our previous question. It's quite similar, but the thing is our previous question didn't lead to quadratic, but this one is lead you to the quadratic. Okay, now because I have a 9x and 3x, then the 2 cannot change, the 3 cannot change, so means that my 9x need to change it to base 3. Okay, why I always from a larger change it to a smaller? Because larger change it to smaller, it's become a positive power. If from a smaller change it to a larger base, the power will become fraction. I don't like fraction. Okay, so now, so 9 actually, okay, 9x actually is 3 power of 2 power multiplied with x, and then these two can rewrite as 3x multiplied 2. Okay, so we remember P and N actually is P and M. They are the same. Okay, so now when I write it 3x over 2 minus 3, this one, I shifted this one to the other side, and this is the time that is I change it into my u. Okay, so I substitute 3x with a u, this one with an u, so I have a u squared minus 2u minus 3 equals to 0. It's clearly you can see that it is a quadratic equation. Okay. Maybe you ask, is it must be u? No. You can change it to y, you can change it to p, or you can change it to z, or whatever alphabet you like, as long as it's not x. Okay? So now this one key in into the calculator, you solve for u equals to minus 1 or 3, and we know that is indices never have a negative value, so this one is rejected. Then I only have my u equals to 3, 3x equals to 3 power of 1, so when the base are the same, my x equals to 1. Okay, now this is the second question. Okay, second type, and the second question for the second type, 25, 10, 5, so same thing, we change it all to base 5, and I don't like have a negative 3, sorry, I think should be negative 1, okay, sorry, this one should be negative 1, and the 23 untouched, okay, so 25 change it to 5 power of 2, x plus 1, and then 10 times 5 to x minus 1, okay, plus 23, and then minus 1, shift it to down, is divided by 5, and then this is 5, okay, this one rearrange, 5, 2x plus 2 actually is 5 power of 2, 5 2x, okay, plus 2 will bring it to in front, minus will bring it down, okay, how? 5n plus n is 5n, 5n. 5n minus n is 5n divided by 5n. Okay, please keep on this thing. And since over this question, I don't have a 5 power of x, I only have a 5 power of 2x. So I substitute my u as a 5 power of 2x. So I have a 25u plus equals to 2. This is 2u. Okay, y 2u, 5 and 2 is 2u plus 23, and my u equals to 1. And then replace back my u as a 5 2x equals to 1. What is 1? 1 is 5 power 0, so my 2x equals to 0, so x equals to 0. Okay, now we look at the first questions for the this one. Okay, so now this question, first thing, we don't know what to do. The thing is, as long as I can change, I will change. 2 power of 4n minus this one, okay, third, 4 actually is power 1 over 4. Okay, and then 16 actually is 2 power of 4. Okay, so negative 1 over 2 power of 4, 1 over 4. Okay, so and then this one they say is equals to 0. This one and this one simplified. P and multiplied n is P and n. So your P for the outside is 1 over 4. Actually is so P4 1 over 4. So cancel is P1. Okay, so this is P1, so I have 2 4n minus 1 over 2 equals to 0. And since I want to do comparison, I can shift it to the other side, 4n, 1 over 2. And this one I can make it to become a negative exponent because I want to have a same base, negative 1. So my base are the same, so I compare my exponent, 4n equals to negative 1, my n equals to negative 1 over 4. So this one is negative 1 over 4. Okay, so the next question seems also quite alike. Okay, so now 4 power of n equals to 1. Okay, I change it to half. This one is big. Why I didn't change it to? Because I look at my left hand side is 4. So I change it to become 4 power of 2. And sorry, this one is an n minus 1. Okay, and since I want to do the comparison, I bring my bring out to become negative. Okay, this one and this one can simplify, and minus 1, 4m plus 2. So m plus 2 equals to negative m plus 1. So my 2n equals to negative 1, n equals to negative 1 over 2. Okay, next. When we look at here, we have a 15, so we know that we cannot do anything, we cannot do the comparison. Normally, the normal comparison is only have 2 terms, if you notice. This one, if you have more than 2 terms, so that means it's not a normal comparison, so you need to do something else. But once you see here is 2x, this is x, so it's already come to our technique of replacement. Let u equals to 5 power of x. So 5 2x actually is 5x power of 2. So this one is u2. So this one is u2 minus 2u minus 15 equals to 0. Since I don't carry my calculator, okay, equals to 0. And then my u equals to 5 or my u equals to negative 3, but since I know this one cannot be, this one is rejected because index cannot have a negative value, so this one is rejected. So replace back my u as in 5x equals to 5 power of 1, my x equals to 1. Settled. Okay, now we look at another one. Okay, so this one is very promising. I only have 2 terms, so we try to do the comparison. So over here have a 4, have a 2, have a 32. So I use the easiest one is the base 2. Okay, 2 power of 5, x minus 1. So now this one is 5x minus 1. This one is 2 multiplied 2 4x. Okay, now when we want to do the comparison, we already know must be pm equals to px. So only have one base on left and right. Okay, so this one have 2. Okay, but remember we have a p and multiplied pm is pm plus n. So this one, although is 1, we still can combine 4x plus 1 equals to 5x minus 1. So my 4x plus 1 equals to 5x minus 1. Shifted here is x. This one shifted here is, this one, this one is 5. Okay, sorry, I might have a careless mistake here. 5, and I shifted here is is a 6. So my x equals to 6. Okay, so if you really see that is, this is the beforehand that is ideally do a careless mistake. Okay, so be careful. Okay, so next one, we have more than 2 terms, so means that it's coming to our replacement. We have 9, we have 3, so change it to a smaller one. So 3, 2x, minus 4, 3x. I don't like there is a plus 1 here, so it's going to become multiply 3 plus 27. Don't touch this thing because they don't come with an x. Okay, now this one, I rewrite 3x minus 12, 3x plus 27 equals to 0. So now let my p equals to 3x. So I have a p square minus 12 p plus 27 equals to 0. So actually is p minus 3 p minus 9, so equals to 0. So my p is 3, so means that my 3x equals to 3, so my x equals to 1, or my p equals to 9, so my 3 power of x equals to 3 power of 2, so x equals to 2. Okay, so this is my answer, x equals to 1 or x equals to 2. Okay, this one is something different. That is, I just want to let you know that is why certain times I don't like fraction. Okay, because if you see that it's when you have a u square versus u. Okay, so we know that is when I want to make this this one to become this, I can just say that this one is square it. Okay, but now where we have a y half versus y 1 over 4. Okay, so how am I want to getting my 1 over 4 right as a title as a y 1 over 4? Okay, so actually we know that 1 over 2 actually is 1 over 4 multiplied by 2. Okay, so now when I want to write my y 1 over 2 actually is y 1 over 4 multiplied 2. So these equations I can change it to become 2p squared minus 3p plus 1 equals to 0. So that's why versus if you have a question, very easy is 2y minus 3 y 2y squared plus 1 equals to 0. So you can see that is whenever it's going into fraction, it look a bit confusing. Okay, now we go to the third one is logarithm. Logarithm is the twin of our index. Okay, so it always need to check is the base. Okay, and over here you learn in your chapter 1 we have two common base. The first one is 10, the second one is e. Why the black color calculator come with these two only, but the others calculator they come with varies of the base. So but the thing is we cater to everyone, so now we only concentrate in base 10 and the base e. Okay, so it happened as our index. That means we need to check our base. If our base both are the same, then we say that is the one inside our logarithm, they are the same. Okay, now this is the most common logarithms equation. If you have a log 3x equals to 4, we can use the formula, the identity or the properties of our logarithm. This 3 bring here means that my x is 3 power of 4. This one is x, I bring out here is x power of 3 equals to 1000, and then it change it to become an index problem. So 10 power of 1000 actually is 10 power of 3, and then since the power are the same, so means that their base must be the same, so x equals to 10. And then when we have this one, same thing, we move our 2 to the other side, is 2 power of 5, and then x over 2, and then I bring my 2 up here, so my x actually is 64. And the last one is I have m power of 4 equals to 81. I try to write in the power of 4, so it's actually is 3 power of 4, so my x equals to 3. Now we look at others than that kind of questions, which is it looks like a index question. When you glance at it, it looks like index question. But the thing is, this question you cannot solve by using index. The main reason is it is impossible for you to change the 100 to become base 1.1 perfectly. Okay? Because when you want to change it, you must make it exactly like the same, but we cannot. So what we do is we take the opportunity going to the logarithm. Okay, the question is 200 multiplied 1 by 1 power of x equals to 20,000. So I divided by 200, so my right hand side is 100, and the technique is take the logs on the both sides. So over here they just show to you that there is a base 10, so actually you no need to write base 10, also doesn't matter. It's understood is base 10. Okay, when you write log only, is understood base 10. So log 1.1x equals to this one. We use the identity, logs identity. This one we can push our x to in front. So I have a log x then it, because we are looking for x. So this one shifted to the right hand side become divide. Okay, by using calculator, the log 100 actually is 2. Actually, it's not 25. Actually, it's 2. And log 10, 1.1 is 0. This is what appeared in our calculator. But definitely, when you want to write like this one, definitely you will not write everything. So, like me, I already truncate into 4 decimal points. So, I divide, this is my answer. Okay, but since you already have the calculator, since you no need to show to others people how you get 2 and this value, actually you can key it into your calculator directly, log 100 divided by log 1.1, and then you get the answer. Okay, and your answer definitely will be different with my answer because my answer is already truncate. Okay, now, and logarithm is said you need to do checking. So if you see that when I do checking, I have a 2 different way. That means I just want to show you what happens if we truncate our answer. One is I use 48.309, another one I use 48.3091. When I substitute into the original questions, you can see that this one is closer to 20,000 compared to this one, but you can say both are not 20,000. Yes, it's very true. Because when we take the logarithm and then we truncate everything, we already start losing the accuracy. Okay, but in this case, we still accept 48.3 something as our answer. Okay, now the second one is we have a 5x equals to 3x. Okay, so you know that it's impossible to change to the similar base, so our solution, take the log left and right. Okay, remember this one we can separate them, okay, because the log PQ equals to log P plus log Q. Okay, so it's over here. Okay, so that's why I separate, and I have another intention is I try to bring down my x to in front. So this is my answer. Okay, and this one also have an x, so we let them gather together. Okay, so I factor out my x and then equals to log 2, and this one, you no need to change it to 5/3, doesn't matter. What you need to do, straight away key in into your calculator, log 2 divided by log 5. Okay, don't forget bracket, log 3. Okay, you must bracket here. Okay, so log 5 minus 3, and then you get your answer. It's fine enough. Okay, and same thing, do the checking, and if you can see that they are quite close to each other, so we are happy with it. Okay, now we have another one question. Okay, now we are quite happy because this one is base 3, this is base 3, but we have one more friend here. Okay, so when we have one more friend here, we can do one style is, okay, this is minus, I combine them by log xy, actually is log x minus log y. Since this is minus, so I become a divide, and this 3 I bring it to the other side, 3 power of 3, and then I bring this one to the other side, and then I solve for my x, and then my x is 2, then still need to substitute back into the equations and get the 3, so means the answer is valid, x equals to 2. Okay, now what if I also have this question? Okay, the question A and B, they are quite similar, but the only thing is only the style you look at the questions. Okay, for example, this one, certain people, they love to change it to become log 2. Actually, if you want to change 3 to become log 3 power of 3, also can. Okay, so that's why you've been exposed have more than one style to solve the same type of questions. So one change it to log 2. Why? Because they in their mind is they want to have everyone have the same base log 2. So everyone have a same base log 2. This is a plus, you become multiplied. So when these two we have the same base, so means that x squared minus 10 are same as 2x minus 2, and then you solve for the some quadratic equation, and then they give you 4 and negative 2, and then do checking, and we found out negative 2 not fulfilled, rejected, so we only have our final answer is x equals to 4. Okay, this is one way. This is the second way. Okay, so I can tell you that these same questions, we also can use the same thing, some way to do it. That is, this one I have a log. As I said just now, 3 actually is, okay, 3 actually is log 3, 3, 3. Okay, remember log 3 base 3 actually is 3. So this is 1 when you bring in 5. Since I already have the same thing, base 3 same, so means that my x plus 25, x minus 1 must be equals to 3, 3. Okay, so this one also can solve by the second method, or you want to solve this question following the previous one also can. Okay, so how you want to solve this question by the previous method is you just bring this one to the left hand side. It's already have the same thing. By the end, you will having the same quadratic equations. Okay, now this is the question without giving you the base. So understood is a base 10. So what I do is, excuse me, I combine them by, I combine everything. So this one I shifted to left hand side, x minus 1 divided by 4x, and equals to 0. So this is base 10, I bring it up, is 10 power of 0, and then I solve for this equation. Okay, now, if I don't want to shift to this side, I can only combine these two. I have a log x multiply x minus 1 equals to log 4x. And since both of them are same, so I can say x squared minus x equals to 4x. So my x squared minus 5x equals to 0. So x actually is equals to 0 and x equals to 5. Actually, this one I think I do something wrong somewhere. Actually, it's a 5x. Okay, so this one actually is x. This one is a 5x. This is x minus 5. Okay, so actually the answer is 5. Okay. Okay, so 5 and check the x equals to 0. Okay, x cannot be 0. Why? Why x cannot be 0? Because as we already know, log cannot be log 0. If you don't believe, you try to find log 0. They will give you undefined. Okay? Okay, so now this is the third type, which you have a something very special base, which is base x. Okay, one is base 2, another one is base x. What we do is we try to change them into the similar base. Okay, now either you can change it to base 2 or you can change it to base x, but my advice is change it to base 2 is easier because it's more normal looking. Okay, but you can keep it as a base x, also another method. Okay, so we applying the changing base. If we want to change it to base 2, so log 2 take this is the original, and the log 2 the base is x. Okay, after that, since this log 2x is something we want, I multiply here log 2x, and the 3 log 2 actually is 1. Then I bring it to here for log 2x, and I change my log 2x into u, so I have a u squared minus 4u plus 1 equals to 0, and my u equals to 1 and 3, so my answer is either 2 and 8. Then I substituting them back, and then I get my answer is true. Okay, so the key over here that is this one don't become like this. If you become like this, then you will say what is this. Okay, so you just keep it as a power of 2, then you will notice this is a quadratic equations. Okay, then the second one is I have a different base. This one seems is okay. That is, we just change it to base 3. Okay, this is base 9, this is base 3. So we change it to base 3. So the first thing, base 3, take the one upper. And then the second one is log 3, 9. This is the base. And log 3, 9 actually is equals to 2. Okay, so then this one, combining that, this is minus is become divide. And then why there is a square, actually this one will bring it here 2, these 2 will bring up here, become power of 2. Okay, and then this one, they use the same technique. Is this 3 bring it here, is 3 0, which is 1. And then I cross multiply, I have my answer is this one. And still the same, doesn't matter what, you need to check the answer, and then these 2 are true, so then my answer is this one. Okay, so unfortunately this one is very lengthy for the checking, but anyhow what they say is you need to do checking, we do the checking. Okay, so now we look at for the class exercise. So this one, not although look like the index, but since they come with a different base, we know that the only way is I take log 5 x minus 4 equals to log 8. So x minus 4 is equals to log 8 divided by log 5. You can straight away press the calculator. X equals to 4 plus a, and then this is your answer. Okay, and then this one also the same, 1 over 3. You don't care whether it's power 1 over 3 or whatever, we just take log. Okay, I bring this one in front, I bracket here, log 1 over 3 equals to log 10. And you don't even need to know log 10 is 1, because what we need to do is we will do log 10 divided by log 1 over 3 minus 3. This one, just press calculator, we solve the problem. Okay, why is minus 3? Because this is plus 3, so I shifted here, so answer. Okay, so this one, nothing different. Okay, so minus x minus 3, okay, bracket, log 2, x plus 1, log 3. And then this one, we need to solve for the x, so negative x log 2 minus 3 log 2 equals to x log 3 plus log 3. This one shifted to the other side. Okay, or I think this one shifted here better, because it will become a positive value. I love positive value. So I have a negative 3 log 2 minus log 3, and then my x actually is negative 3 log 2 minus log 3 divided by log 3 plus log 2. You just key in everything into your calculator, will be fine. Okay, now this one, more than 2 terms, so you already know that is you can do some magic. Okay, now this one have a similar base, so I no need to think much. I bring this one up, I have a log x squared equals to this one is a plus, so I will become multiply. Okay, and since both are having the same base, so I can say x squared equals to 6x minus 8, so x squared minus 6x plus 8 equals to 0. So my x actually is 4, or my x equals to 2. Oh, one more thing. Maybe you already noticed that is I didn't do the checking. Okay, so please do the checking. I didn't do the checking, so it's my fault. Okay, so you need to do the checking. Okay, so now when we look at this one, different base, so I change the base x to base 4. Okay, then this is 2.5. Okay, then this one cross here, log 4x power of 2 plus 1. Okay, log 4 is 1 equals to 2.5 log 4x. So now I have let my u equals to log 4x. So I have a u squared minus 2.5u plus 1 equals to 0, and use the calculator. Okay, I really use the calculator, and the calculator give me the answer. And then don't forget my u actually is log 4x. So x is 4 power of, okay, let's say this is a, this is b, so 4x, this is 4 power of a, and so on. Okay, now this question, you have base 7, 49, 1 over 7. Okay, you can interchange of them, but the thing is for us, first I said I don't like fraction. Okay, and the second thing is 49 and 7, the smaller is 7, so we choose 7. Okay, so I have a log 72 plus log change base 7x log 749 equals to log 7 3 over log 7 1 over 7. Okay, so this one actually is true. Log 7 1 over 7 actually is negative 1. Okay, and we can combine log 2. Okay, so depends on you whether you cross multiply here or you want to bring the other side. So I'm quite lazy. I just use x power of 1 over 2 because 1 over 2 bring up. Okay, 1 over 2 log 7x actually is log 7x 1 over 2. Okay, and equals to, okay, this is log 7 3 divided negative 1, it will become, this one bring it up here, will become negative log 7 3 negative 1 over 2. Okay, so this one is log 7, okay, sorry, 7 3 1 over 2. So now I can say x half actually is 3 half, and then my x half actually is 3 half divided by 2, and my x actually is 3 half over 2 square. Okay, so I think, okay, sorry, I have a negative. Okay, sorry, I have a negative. See, I always be so careless. Okay, so this one I need to bring it down here. Okay, so this one power, okay, 3 half 2. Okay, so it's become 1 over 3 half 2. So it's 1 over 12. And over here I say do the checking. So you just substitute everything inside. Okay, so you will get the answer. Okay, so then over 2 in the chapter 2.1, we have 3 different types of equations: surd, indices, and logarithm. For the surd, the technique is try to keep the surd at one side, and then we keep on squaring to get rid of the surd. And the indices and the logarithm are the same, that is, we need to alert with their base. Once their base are the same, so we can say they are the power or the others, the exponent are similar. Okay, and or then after that, if there are certain times that you need to rename them into U or P to ease your problems. Okay, and for logarithm and the surd, you need to substituting back into the equation to verify your answer. Thank you. See you in next video.